So, hello, Dr. Su. Thank you so much for accepting this invitation of doing this video interview. It's an honor to have you here. I guess it's the first time a science-based channel is inviting someone, a dermatologist like you. So before beginning our talk, I will read your bio, introduce you to all people here in Brazil.
Okay.
So Dr. Nan-Yao Su is recognized nationally, internationally as an authority on termite and is known for his innovative approach for their population management. He authored and co-authored over 260 peer-reviewed articles and book chapters on termite biology and control. His studies on the population ecology of subterranean termites and slow-acting toxins led to the development of a bait system for population control of descriptive pests. The laboratory screening criteria and field procedure he designed has been used worldwide. Commercialized as the Sentricon system, it has been marketed in 18 countries since in 1918 and 1995 to protect over 3 million homes and reduce pesticide use by greater than 9,000 metric tons. So it's Dr. Su has served as a technical advisor relating to termite issues for foreign governments such as New Zealand, China, Vietnam. In 2009, he established the Nan-Yao Su Award for Innovation and Creativity in Entomology of Entomological Society of America. So for this bio, thank you so much for having for your time and take your time to be here. So I would like to ask you some questions regarding the first one is this partnership with universities. Like you work for University of Florida as researcher, right? And then your research with foraging termites was sponsored by Dow AgroSciences. How did it started? Like you started as a basic science research with foraging, and then after Dow AgroSciences sponsored you, or Dow was sponsoring you at the very beginning? Can you tell a little bit about the story of Sentricon?
Okay, so yeah, I mean, I started just like every dreamy, ambitious graduate student. I started studied termite because I would like to resolve some of the evolutionary question of termite. So being social insect, termite really does not fit the model that the Charles Darwin described as the basis of evolution, which is individual fitness and individual selection. What Darwin says is that if an individual is more successful in that environment, he can outcompete with the other individual, and therefore he will leave more in the offspring to the next generation, and therefore that's how selection starts, and eventually most of the species will possess the same characteristic of that individual. Now that's kind of that, in a nutshell, that's what the Darwin's individual fitness, individual selection theory is about. So, but that's the entire thing is based on the individual. The model really does not explain why social behavior of termite evolve. If you can see, the problem with termite is that within a colony of million termite, for example, only one individual reproduce, queen. The rest of the individual worker soldiers do not reproduce, yet they work very hard. They even sacrifice themselves to help the mother reproduce their sibling, but they themselves do not reproduce. Now, if they themselves do not reproduce, then how can they leave their characteristic into the next generation? It really doesn't explain, if you use the individual fitness of the Charles Darwin, it really doesn't work out very well. So when I was a graduate student, I thought maybe I would think about that problem. I would like to, provide some answer. That's kind of how we started with termite, right? Every student does that. But then when you study termite, the problem here is that next thing people know when you study termite, what next question they ask is that, I have termite in my house. How do I control it? Right? So that's basically most of the question I come up with. So with that, I just say, okay, I mean, maybe I should kind of study how to control them too, because otherwise it's kind of whatever I study, maybe not that useful for the public. That's how it started. Okay.
So your first question was how did the termites and social insects have this kind of social behavior of this like altruistic behavior, and then you move to the next question: how to control them? Yeah.
So what happened is that when I tried to study how to control termites, one thing I realized that at the time, and still is, that most of the time when termite, you would have a termite, subterranean termite in your house, they're a pest control company, and they're coming and spray tons of pesticide, lots of pesticide around their house. Mm-hmm. Yeah, and that's basically the soil treatment technique that everybody's using since 1900, right? The problem there is that it doesn't take a genius. It's to figure out that. So what happened to the colony underneath it? It spray a bunch of pesticide underneath your house, but these termites have a million of termites, and some of them are actually 300 feet away from you, 100 meters away from you. They're not going to affect them. Besides, when you try to create a chemical barrier, you're not going to have a complete barrier by trenching or drilling, injecting. You know what I mean? Mm-hmm. Your house is sitting on a piece of soil. You have to lift the house up to the air, spray pesticide underneath and put it back. That you have a complete barrier. You can only do that before the construction. After the construction is done, you can't do that. So here we go. We have an incomplete barrier. A termite is still there. Or what's going to happen eventually, right? One termite going to go back to your house. Or if they can't go inside there, they go to next door. And the swarming system come there, swarm, and go to somewhere else. That we are really not solving the problem, the real problem, by just spraying tons of pesticide around people's house. And that is where I started to begin to think that I had to kill the colony underneath there. And that is the initial debate come up with this. So when I tried to do that, of course, I identified what is really what kind of pesticide I need to have to do this, right? And eventually we identified two characteristics. One is I had to be slow-acting. You cannot kill them right away. So the termite eat the bait, have to go back and give it to someone else. The other is the non-repellent. I know you cannot chase termite away. You want the termite coming in and eat. So when I identified the characteristics, I wrote a letter to many chemical companies, including Dow, and just asking if they have some chemical like that I can use. Okay. And some company responded, some did not. And Dow responded to me, and then that's how our relationship started. Now, they respond to my idea of developing a bait. And all the basic study is mine. Foraging behavior is really my study. I have nothing to do with them.
Okay. So actually you're studying how to reduce the pesticides in the environment and trying to develop a base system, and contacted lots of pest companies, and one of them, which is Dow, agreed to build with you together. Mm-hmm. Okay. Wow.
So many companies did give me chemical too. Okay. And I tried them all, and none of them worked very well. And the only thing worked was the Dow's at the time, a compound they gave me called hexafluorine, and that is the only one that I was able to kill the colony.
Wow. They by themselves were also building a bait system as well, and with extra fluorine, and then you tried to develop in your lab, or was it how did it started? Like you started testing their product, or you developed the product?
No, when I was testing, they had no product. There's no product when I was testing. So initially, when I get the pesticide or active ingredient from chemical company, I would test in a lab to see if it fits into my criteria or not, to see if it's really slow-acting, or what concentration I need to use to make it slow-acting. And also have to find out at what concentration they have repellency, because those selecting or repellency is all concentration dependent. Anything, even perfume smells good, increase the concentration, smells really bad. Okay, it's everything concentration, right? And even selecting compound, if you increase the concentration, some of them actually will kill very quickly. So you have to determine what is the concentration you need, and to see that it's going to work or not. And so we run a series of the tests, laboratory style tests, to see which compound actually is promising, which is not. And only those are promising, we go to the field testing. And of course, even with that, most of the compound I tested in the field fail, just did not work.
Yeah, that was one of my next questions. How did you test it in the field? Because in the field, you have no control over the foraging area, depending, like a subterranean must be like large areas. Like how do you separate and mark the termites, right?
Yeah, so I was very lucky because by the time I started my PhD program at the University of Hawaii, my major professor and previous graduate student already developed this marking technique and the trapping technique. So I kind of used their technique to do the field study for subterranean termite. So typically, if you have your house that have infestation, termite activity is in the soil somewhere around it. So you put a wooden stake around that house. Then we go check the wooden stake. Now, and if you're infested, you can take the stake and there'll be a bunch of termite in there. Then we set up a trap in the ground, the block of wood inside there. And we have many of them around people's house and in the backyard and everywhere. Then we start using correct termite back, mark them feed them with a filter paper containing certain color. And sometimes can be blue, sometimes can be red, and turn them into blue termite or red termite. And then release them back to one station. Then we start to find out, check to see where would they appear in which station. Now, if they appear in the station, we know they are all interconnected in the ground. That is one of the colony there. They connect all the traps with color termite appear. Those are one colony. And that's how we determine the colony.
How does long staining, this dye inside of the termite body in a worker?
Depends what kind of dye you use. Red color sometimes will last up to 2 months, 1 to 2 months. But the red one, Sudan red 7B, if you try to stem them too much, you end up killing termite. So they cannot use a very high concentration. Then later we found another dye called Nile blue, the blue color. That one is real long lasting. It will last up to like 7-8 months.
Wow.
So yeah, once it's stand there, it kind of stays inside because the dye actually get into fat body of the termite and they kind of stay there for a while.
What are your thoughts in when you have large areas of subterranean termites invading a neighborhood? How does it work, the system in the United States? Like it's pest control company together with the neighborhood and the government. How does it work to control all of these areas?
Research and the pest control company application are two totally different things. They don't have to do that. That's our job. That's my job. My job is to mark the termite, right? If I find that the colony here, maybe go to next door, I know exactly where they're connected. Then to test to see if the bait work or not, I would pick up one station and I put the bait in there. Then I'll start measure from the other interconnected trap to see activity is going to decline or not. If in the base station termite run away, no longer have a termite, but the other base station still have a termite, I know, whoop, they're avoiding my bait. That's what right? Now, if I put the bait in one station and slowly the activity of the other station start to decline over the time, slowly decline, I know I'm affecting the entire colony. So we do that kind of study again and again and again, repeat it many times to make sure it's happening with this particular bait we're using. After we establish that it's true, then we develop the product, hand it over to pest control company, and they do not have to do this market capture anymore. They don't do that kind of stuff.
They
because
don't
they
have,
know I
okay.
already give a test for them. I already prove it. Okay.
Okay, so the Sentricon system guarantees the control over a certain area. So the pest control company doesn't need to monitor them like what you were doing with staining. I was thinking, you know, sometimes some pest control companies, like for flies, they have these devices to monitor like the activity. So for Sentricons, just to take the bait out of the
No,
device?
it's that. So what happened in the pest control company in the practice is that they will have a bait station around people there, and they will check those stations to see termites is there or not. If the termite is still there and they eat the bait and the bait is consumed, replace another piece of bait. And that's how the monitoring is. You know, they don't have to say, you know, what happened the next door or anything like that. That's not their business. Their business is to make sure that all the installed stations have there, the bait is still there, and the termite is, after a while, if the termite disappear, you know, you kill the colony already. You go back to put the bait in and just continue to watch them over the time.
Okay. And do you have studies in like for Sentricon as time passes, like here in Brazil, it rains a lot. So I guess this raining would allow like to the bait to be moldy, sometimes with fungi. What are your thoughts on that? In humid areas?
So early Sentricon station, exactly that's the kind of thing I was afraid of. So early model of the Sentricon station, we do not put the bait in from the beginning. We put a piece of wood inside there. And when you find out that the termite, we put the bait in. So, you know, we don't have this. So, you know, the termite need to eat the bait. So we don't have to worry about this problem. Yeah, the problem for doing that early product of Sentricon station, which we call the monitoring baiting protocol, because you put the monitoring first, and when you find termite, you switch to the bait type of thing. It's very labor intensive. As you can imagine, pest control company have to go there on site, check all the station, and they replace with the bait, and they go back again. Okay, so that is just too labor intensive. So I invented another version of it, which is the durable bait. Basically, it's a bait, durable bait. It's a bait that, regardless of the climate condition, water, whatever, will stay active.
Wow.
So that the bait is protected by polymer, plastic, and it will stay in there. So the current version of the Sentricon station is called, they use a bait called Recruit HD. That's called high density. And it's a very, very compact, heavy bait. It's all protected by plastic. It will stay in the ground regardless of what condition, or even if it's raining a lot, doesn't matter because it's protected by plastic anyway. And it will stay, that's some data I show it will stay in the soil for up to 7 years, still active.
Wow, 7 years. Yeah, that's a positive point regarding Sentricon, because here in Brazil, I've seen some products that try to imitate Sentricon. They put the same device and then put a wood and pulverized with another insecticide. So but this doesn't guarantee that termites will be attracted to that, and also that for these other adverse environmental conditions, right? For this protection.
Well, not only Brazil. I mean, there are many copycat products of Sentricon all over the world.
Not only Brazil.
No, I've seen them in China. I've seen them in Vietnam. I've seen in Thailand. I've seen everywhere. But they usually don't work very well. So, you know, so that's kind of sad, because it's kind of give bad name to bait. But, you know, what are you going to do, right?
Yeah, because it's I think they just put the active ingredient on that, the exflammon, the concentration, and then think that it will resolve by itself just by imitating this. Yeah. But let me ask you another question. What are the impacts of an introduced species? Like, I know in the United States you have Reticulitermes, which is an exotic species. Here in Brazil we have Coptotermes gestroi. And what are your thoughts on these environmental impacts? And another question together with this, I've seen a work from Thomas Schuvenach. I think he's your student, and I've seen that there's a problem in Florida that the two species from Coptotermes genus were hybridizing, like and then making like making huge colonies. Like they were recognizing like themselves like Argentinians, forming like huge colonies. Like, what are your thoughts on this environmental aspect, and how do you think as a global, like, what can we do to prevent this kind of exotic inventions?
Well, introduced species, invasive species are a real problem, but it's all man-made. We are the one carrying them around. The Coptotermes gestroi in Brazil, as you know, is a very serious pest, but it was introduced. The gestroi is originally from Southeast Asia, and it's a very tropical species, and I'm sure they have moved into the niche previously occupied by your native species, and kind of chase away your native species from one spot to the others. That same thing with when Coptotermes formosanus, Formosan termite was introduced into New Orleans. After a while, you don't see any native subterranean termite anymore because it's all replaced by formosanus. We found the gestroi, Coptotermes gestroi, the same species in Brazil, in the late 90s in Miami in 1996. And we thought that would be staying there because it's a tropical species. And Florida is actually not exactly tropical species region. We are subtropical because we are not really even close to the tropical cancer, to the equator. Tropical cancer in the northern hemisphere actually close to Cuba. So it's way below us. But because we have our Gulf streams washing us, it tend to be a little warm, but we're still not quite classified to be tropical. We are subtropical. So gestroi is not supposed to be in Florida, but we found them in 1996. And initially I thought, oh, well, they're probably not going to go anywhere. Well, guess what? Since then, they moved north, slowly moved north from Miami area to Fort Lauderdale. Now we found them in Palm Beach. And then with that, area we found them began to overlap with the Formosan termite. And those two are both the Coptotermes. And they probably spread from the parent species probably 8 to 10 million years ago. And since then, they've been separated out. We call allopatric species because they're in different regions. One is supposed to be in tropic in Southeast Asia, but the other is like in Taiwan and in Japan, and in the more like a temperate and subtropic. But now the temperature has changed, and we move them around, and then they are kind of overlap in the distribution. But that usually does not mean that two species will mate and create a hybrid. They usually don't. They still have a mechanism to separate those around. But really peculiar case are happening in my area is that because of climate change, Formosan termite began to swarm a little earlier, and gestroi began to swarm a little later. And because of that, swarming season began to overlap. Usually before, gestroi used to swarm from February until late March, and Formosan Coptotermes formosanus tend to swarm from April to June. So the swarm doesn't meet each other. Now, gestroi actually swarm from March to April, And for most of the termites, start also swarming from March to June, July. So we have this peculiar situation because I think primarily because of climate change, that the swarming timing is slowly changing, and distribution pattern status change, and they can survive guess rate despite being tropical species. They can survive the winter of the South Florida too, because our winter here is not that cold anymore. So that will create a hybrid, chance of hybrid species to appear. Now, what's going to happen is this hybrids, we don't know. Are they going to produce F1, which is their next generation that will begin to reproduce? If that's the case, we are talking about formation of new species here, or they will die out and be absorbed back by the parent species. We shall see. But this is not just a termite problem. We've seen this kind of thing all over the world.
But so there's no conclusions regarding the viable generations coming from this hybridization. Like
we don't know. We don't know. We are trying to get funding to go out to the field to see if the hybrid population already exists in the field or not. And if that hybrid population are viable and continue to thrive, it had to be found in some place like Taiwan, because that is earlier hybridization happened over there. Because Taiwan and Philippines are very close. The Philippines have a gastrate, and Taiwan have homocenos. So those two species probably interact with each other for quite a long time. And if you're going to find viable hybrid population, it has to be somewhere in southern Taiwan. And one of my ex-students is in Taiwan right now, and he is kind of looking into it. So shall see.
Yeah, that's nice. So there's no studies regarding Sentricon control with this hybrid species. Like it's
it'll kill them. Yeah, it'll kill the colony. It's effective.
It's effective regarding
genus. Yeah, most species that we use today will kill the hybrid. That's not a problem.
Oh yeah, that's nice. Dr. Su, in Brazil, I guess in the United States as well, we can see that people sometimes are selling ultrasonic devices that promise to repel termites. I also saw research on a device that is mimicking ant steps. What is your opinion about? Could you tell us more about myths of devices, techniques, and control methods that don't work regarding termites control?
Well, ultrasound device, right? That is what's being sold all over on the on the TV commercial to repel cockroach, ant, and bad insect, but does not harm your beneficial insect. I said, come on, it cannot be like that, okay? it probably does not work, and if you do a lab study, it may work first few minutes, but most insects get used to it. If you have a noisy sound, even bird or anything, you can scare them first few minutes. The minute they find out if nothing doesn't hurt them, they're not gonna run away. Come on.
That's not going to work. And what about this study of I saw research that scientists were recording ant steps and put in this sound of ant steps inside of a termite colony, and it seems that they go away, like they perceive as a
but you see, the problem here is that you create a sound and they say, oh, ant is here, let's run away. Then they find out it's not true. Don't you think they're going to come back and even hear the ant sound around there?
Yeah.
It's called learned behavior. So you'll be surprised that insects can learn, and they learn very quickly. And most animals can learn. Even amoeba can learn. So the very classic example of the learning behavior of the amoeba is that amoeba hate sour thing. You put a piece of vinegar, drop of vinegar in the petri dish with amoeba. They look at the microscope. Amoeba run away from the vinegar. Okay. So the study they did it this. Before you put a drop of vinegar in there, you put a light in there. You put shine a light, then put a drop of vinegar, and you do that a couple of times. Next thing, you shine the light along, amoeba run away. They don't know the vinegar. Now, if they normally amoeba does not respond to light, but they can sense it, but they don't run away. Okay, but they associate the light with the vinegar, and very soon they run away. But if you keep the light on without vinegar, they don't run away either. So they learn very quickly those things. So living thing is very, very well programmed to adapt to the environment. So you cannot fool them like that. Now, walking sound of ant is interesting idea, but I think as usual, I mean, they probably walk for first few minutes. And then my partner learns that, oh, there's nothing there. Now, just think about it. If you go to the field and you flip a piece of rock, a piece of wood in the forest, it flip over there, right? And often you will see termite nesting is here and ant nest is here. There's a wall in between.
Wow.
They're right next to each other and they live cohabitate. And I'm sure those termites can hear the step of the ant all the time, but they don't care. They live together like that. As soon as the wall separate them, they're okay.
Wow, I didn't know. I thought they would like predate them as soon as a termite steps in an ant colony. No, it's not like that.
If occasionally ant break the wall and get into termite colony and snatch a couple of termites here and there, termites will build another wall behind it, and they go into peaceful coexistence again. So, you know.
Oh, I didn't know. Thank you so much. One more question, Dr. Su. In the US, I saw it's common to do tenting, but if we have an area infested with different species of termites, what would be the required treatment control? Is it possible to combine different modes of action modes insecticide, like using hormone growth regulation, pulverizing a bait plus Sentricon? What are your thoughts? Because here in Brazil, we have problems with Nasutitermes, Cryptothermis, and Coptothermis. Like one is arboreal, another subterranean, and we're still studying the subject. We used to study the germline hormone analog. That's hormone, germline hormone, that will convert worker into soldier cats. You can create tons of soldiers. And then soldier, with so many soldiers, they are basically, a colony will collapse, right? But we find out that work only certain species, but does not work on the other species. And hexafluorine, belong to a group of compounds called urea benzoate, and that tend to inhibit the formation of chitin in insect. And when we try to do this on higher termite, like Nasutitermes, number one, they don't seem to respond. And it kind of didn't surprise me because even with the chitin synthesis inhibitor, it's also very species specific. Some CSI will be active against some species, but not the other species. That's very common. Okay, so as far as the Nasutitermes is concerned, yeah, I mean, if we looking into it, I'm sure there's some compound will work, some hormone will work against them. It's just as a matter of how much resource you want to put into looking into it or not. Or you may need to have some fanatic person like me 30 years ago, just keep doing it, eventually you find something. So it's more about testing, like independent the context as well, right?
Well, Nasutitermes is, one problem with the higher termite is that there are many workers what they call terminal cast. And when they get into the terminal cache, they don't molt anymore. And they just stay within the terminal cache like that for quite a long time and continue to work. And the chitin synthesis inhibitor does not work if you don't molt. So, so that's kind of one reason why it does not work, I think. But I don't have a naturally terminus in my place, so I really don't have a lot of more experience than what I can, confidently say what's going on there.
Okay. What about cryptothermos brevis infestations like drywood termites? What are your thoughts about control this species? Because here it's most, as far as I know, it's most like pulverizing they are infected, or you just throw away the object. Do you know?
Well, in the United States, drywood termite is mostly fumigation. You tent the entire house and put the fumigant in there, kill everybody inside the house. That is the most effective control method. Tent. Because drywood termite is really different beast. Typically, they form a very small colony, and but you don't know where they are. Okay, so if you have a beginning, or if you're lucky enough to find where they are, you just have to inject pesticide into the colony. You kill them off. The problem here is that how do you know that's the only colony you have for the entire house? You don't. So Cryptothermis brevis type of drywood termite is that if you have a good detection technique, you probably can get away with a spot treatment, just inject pesticide into the colony one by one, if you can find them all. But we don't have that. We don't have that kind of technique at all. So you end up fumigate the entire house in hope that you kill everything in the house.
Okay, that's why in the US it's common to do this tenting technique. I guess it's just in the US. Here we don't have, as far as I know. So is there a legislation in the US that before you build a house you have to do this treatment area, and then there's an insurance regarding that if there is a revision of a swarmers?
In the United States, in the state where you have a subterranean termite, most of the building code, that is a code rule regulation by the county, will say that you have to do something to make sure you don't have a termite infestation in the future. And that's the law. So you have to do something with it. Now, it used to be they would spray a bunch of pesticide in the soil before they pour concrete on it. And but in Florida, in some states, now you don't have to do that. If you prefer to use the bait, you can put the bait around people's house and just kill the colony, and that is acceptable too. But those are dictated by the building code law, except that it's a county by county. In some county, for example, they don't have that kind of requirement. Around here in South Florida, Miami-Dade County, a building code does not say anything you have to treat. So you don't, if you don't want to treat, you don't have to. Except that most people borrow money from the bank to build a house, okay, the mortgage. And bank will require that you do some treatment because that belongs to bank. The bank doesn't want to lose their house to termite. So bank doesn't require them to do it. Yeah. But if you are very rich, you pay the cash or the pocket to build a house. If you don't want to treat, you don't have to.
You were invited to come here to Brazil, I think, for this termitology symposium, but it happened a cyclone over there.
I know. I was supposed to there 2 years ago in the summer.
In the summer, yes.
Last minute, there is a hurricane coming in.
Hurricane.
I cannot abandon my family and go there.
The researchers that I would call to come here, they went to the symposium, to the dermatology symposium. So we would do was a debate. I don't know what would be like if there was a translation. I actually don't know how it happened, but I think it was 3 people, two researchers from here, from Brazil, to discuss termite control, isn't it?
Yeah. Well, I'd love to go back to Brazil. I used to go a lot. I used to go back to Brazil.
Seriously?
Yeah, I used to go back to Brazil and give a seminar about data here and there. Actually, I was asked one time to see if they can use a bait to control termite in the sugarcane field. And so we went to sugarcane field. I was looking at can we apply termite bait to control termite? That I think it's a coney species in those sugarcane. To make a little
yes.
And then with the system I have, I just don't think it's possible. So that is another reason why I've developed a durable bait, a bait that will withstand in the environment. And with that durable bait wrapped in a particular plastic, you can probably drop those bait all over the sugarcane field, and the termite eat them and kill them. And that's probably will work. But yeah, that was kind of interesting experience. Yeah.
Oh, wow. So it was in the sugarcane field. Where in São Paulo, in Northeast?
Very, very south. I forgot the name. God, Magua, not Maguasu, somewhere around there. Yeah.
Mongaguá? No,
yeah, something, I forget the name, sorry.
No problem.
Yeah.
So it couldn't, so you came here to test the bait system for
No, I was
terms.
just looking at the situation to see if it's all even cruisable or not. And, but we have a new durable bait now. It's probably possible, but again, we don't even know if the active ingredient will work on the coney-termis. Nobody never tests that, so we have to test that one first.
Okay, so actually, the bait system works more in urban areas, right? Rather than in the field.
It's mostly work against coptotermis and reticulotermis, and another couple species, another genus, it works very well. But higher termite is really a bit tricky. Nasuli and things like that, or coney-termis, a little tricky. Yeah.
Okay. Okay, Dr. Su, I guess I asked you all of the questions now.
Okay, very good.
Thank you so much for your time. Okay. See you next time. Thank you so much. Bye-bye.
Bye-bye.
Have a nice day. Thank you.